All right, good, excellent. Now momentum is represented by the letter P, as in Paul, the letter P. And that equals a product. And the product, try to stay awake everybody, the product is mass times velocity. Okay. If I take a mass, such as a medicine ball, it's heavy, okay? This has mass, correct? And if I throw it, it's going to have velocity, correct? That's it. That's momentum. Now, momentum is really only noticeable when you had it and then you don't have it anymore. For instance, if I have a car and the car is, let's say is, the car is 2,000 kilograms. Is that okay? It's reasonable mass for a car, would you say? Yes or no? Okay, easy? Okay. And the velocity, let's say you're on Satuba Road out here and you're only going, actually if you're going this speed you'd be racing, but let's say you're going 40 kilometers per hour. Correct? Yes? If I write 40 kilometers per hour, is there a problem with those unit labels? Is there a problem? What are the SI units? Kilograms? What's the SI unit for length? Kilometer? Or what? You just took a test on Newton's laws. What are the SI units for length? Meter, correct? And what's the SI unit for time? Nobody? What's the SI unit for time? Seconds, okay? So let's change this. We'll go 40 kilometers per hour, and we'll multiply that by a ratio where the kilometers will cancel, and I've converted it to meters, and then I'm going to convert it from hours to seconds, 1 hour. So somebody for me, John, you can take out that incredible calculator of yours and say 40 times 1,000 divided by 3,600. What do you got? Anybody? You get it? What do you got? You're just going to keep the answer to yourself? Okay, I need to. We're having a math problem. 11.1? Can we just say 11? Is that okay? I feel like I'm calculating the launch code for our missile launch to the moon. 11. Okay, 11. Okay. So this is 11 meters per second. Okay, good. So, what's going to be the momentum of this? What's going to be the momentum of this car? Well, you have a calculator? Can you help me out here? So it's going to be 22,000. It's going to be 2,000 kilograms times 11 meters per second.
22,000.
What is it?
22,000.
22,000. 22,000? Really?
Yes, 22,000.
22,000. Okay, good. So 22,000. And what are the unit labels going to be for momentum? Anybody? What are the unit labels for momentum? What is it? What are the unit labels for momentum? Nobody? Well, isn't it kilograms, meters per second? Aren't those the unit labels for momentum? Yes? Okay. Now, I'm going to erase some of this other stuff. Is that okay? I'm going to erase this. I'm going to erase this. I'm going to erase this. Okay? You okay? That's a problem. You can have that on your test. It's easy. What's the momentum? The momentum is the mass times velocity. Sounds almost too easy. Well, it is. But that's a question, that's an answer. Okay? Now, if I hit a brick wall and it stops dead on, instantaneously, we'll say it hits a brick wall and the time it comes to a stop is 0.001 seconds. That's a pretty standard time for something stopping instantly. It took some time to stop, but let's say it stopped in 0.001 seconds. Is that okay? You all right with that? Okay? Okay? Okay. So, there's an interesting concept. It's called impulse. An impulse is something you don't notice until the momentum disappears. Till it disappears. If it hits a brick wall, what's the change in momentum? What's the change in momentum? If that car hits a brick wall, what's its new velocity if it hits a brick wall and stops instantaneously? What's its velocity?
0.
0. So what's 0 times its mass? 0. So if it changes momentum, so it stops, what was the change in momentum? Well, it was 22,000, now it's 0. So what was its change in momentum?
0.
No, what was its change? Dude, it had a momentum of 22,000. Now it has a momentum of 0. And you always say final minus initial, always. So you say change in momentum equals final minus initial. Always. Always. So, what's the final momentum of the car?
Negative 22,000.
No, I didn't ask you that, dude. You're giving me the answer. I don't want the answer. I simply asked you a very specific question. What is the final momentum of that car?
0.
0. Good. Excellent. 0. What was the initial momentum of the car? 22,000. Right? Yes? So what's the change in momentum?
Negative 22,000.
It's going to be negative. Negative's important, right? It's like deceleration. When you slow down, the acceleration is negative, correct?
Yep.
Okay? I'm going to give myself a room here. 22,000 kilogram meters per second. Okay? So that's negative. Right? So now it's huge. Now it's huge. The change in momentum will equal the impulse. That's the change in momentum, and that equals the impulse. Now, the impulse is actually very simple. The impulse is, we say I, right? I for impulse, right? And the impulse equals force times time. Ft. 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 Now, let's just go over here really quickly. You know what force is, right? Force equals like mass times acceleration. So force is newtons, correct? But it's going to be kilogram meters per second squared, right? Right? Isn't it? Yes? So if I take kilogram meters per second squared and multiply it by seconds, time, what do you get? You get kilogram meters per second, which is the momentum. So it fits. Yes? So the change in momentum will equal the impulse. Now this is, I'm right there. I got like 2 minutes left. You ready? And then we have 2 minutes for an applause. Kidding. Okay, so let's erase some of this stuff. Let's clear the board a little bit. Okay. So I say 22,000. That's the change in momentum, negative, equals Ft. You can say delta T or just T, it's okay. It's a change in time. Yes, it's okay. Now remember, let's get rid of all this. Remember the T was 0.001, correct? The change in momentum is equal to 22,000 kilogram meters per second. Okay?
It was negative.
Negative, thank you. Okay? So, time, this is the change in momentum. Right? And again, time, we'll just say T, is equal to 0.001 seconds. So, we have 22,000 kilogram meters per second squared equals F times 0.001 seconds. What's F equal? What is 22,000 divided by 0.001? What's 22,000 divided by 0.001? Hope you don't need a calculator. It's called base 10. What you guys have done with slide? 22,000 divided by 0.001. So how many zeros are there? 6 zeros, right? How many zeros here? How many zeros are here? Right? So you're dividing it, and you're going to get 3 additional decimal places, right? So it's going to be equal to F, wait for it, is going to be 22 million newtons. I have a force of 1,000 newtons. Okay? You're in a car that's hitting a brick wall. That's like 1,000 of me standing on you. Would that hurt?
Yes.
That would really hurt. Now, the question for tomorrow is, A, are driving cars dangerous? Yes, and this is why. It's why. Question 2, how can you make a car safer, and how does it make it safer? Mathematically, there's an answer. We know as people who have been in cars our entire life, either by driving them or being a passenger in them, what are some of the safety things that are in cars that make them safer?
Seatbelts.
That's big.
Airbags.
Seatbelts,
Airbags.
airbag. What else? Believe it or not, this is crazy. Padded dashboard. The dashboards when I was a kid, I'm not kidding, when I was a kid, you know what the dashboards were like? Metal. They were metal. No padding, nothing. They were metal. And we didn't have seatbelts. Didn't have them. And we certainly didn't have airbags. And what's the fourth thing? All came about since I was a kid. Didn't have any of these four things. Your car especially. If you hit something, what's going to happen? The front end is going to crumple. So you have crumple zones. Now the question is this. You've got to know why those work. Tomorrow we're going to tell you. You may already be able to figure it out. It's certainly in the book. It's one chapter. This is just chapter 8. I want you to read it tonight. Understood? Yes? Okay.